Let's start talking about quadrilaterals and polygons on the SAT. Those are two geometrical figures that are pretty simple, few things to remember and easy application. So let me share my screen as always. Let's talk and let's start talking about quadrilateral. Now, the classic quadrilateral that we know are rectangles like this one and squares like this one. How do we find the area of any rectangle? Will be base by height or length by width. Doesn't matter. In a square, base and height will be the same. So the area will be just side by side or side to the power of 2. Important things to any type of quadrilateral, the internal angle will always be sum of 360. And also exterior angles should sum up as 360. That's it about quadrilateral area. Now, there are other types of quadrilateral, like, for example, a trapezoid. The trapezoid is the characteristic that it has two bases, and one of the bases is always bigger than the other base. So the formula to find the area of a trapezoid is actually 1/2 of the height multiplied by the two bases summed together. Let's say that you don't remember this formula. It's okay. At the end of the day, a trapezoid is just a rectangle with two triangles next to each other. So you will need to find the area of this triangle, the area of this triangle, and then the area of this rectangle. It's doable. Or there are also other methods to find the area or other information regarding a quadrilateral. For example, the question here say in a square ABCD above, the length of a diagonal AC is 5 square root of 2. What is the area of the square? We want to find the area of the square, but we don't have the side, the length of the side. But we have many information regarding squares. When we deal with a square, we know that each side is the same. The sum of the interior angle is 360, but also each angle is 90. So when we have a diagonal like AC, then automatically these angles are just going to be of 90, meaning 45. For this reason, we can use special right triangles, and we have seen the special right triangle when we talked about trigonometry and geometry, triangles in the specific. So we know that we can use that ratio to find the information regarding the sides. So the diagonal in this case corresponds to the hypotenuse of that triangle. So we just need to do s square root of 2 that is equal to 5 square root of 2. That will lead us to have this, the side will be equal 5, which is also the dimension of each side of this square. So the area of this square will be just 5 to the power of 2, which is 25. That's all. What on this recognition, remember that when we draw diagonals on our rectangles, each segment of this diagonal will be equal to each other. So AE is going to be equal to BE, that is going to be equal to CE, that is going to be equal to DE. That will make easy to find also the area of each of these triangles. AED will be equal to the area of the BEC, BEE will be equal to the area of CED, and so on. There is another type of quadrilateral, which are parallelograms and rhombus. The parallelogram is a quadrilateral with two pairs of parallel opposite sides. So here we have this parallelogram, and we have these two parallels, and these are the two parallels. Clearly, there is something different in here. In fact, we know that AB is going to be equal to CD, and BC is going to be equal to AD. We know that the angle BAD is going to be equal to the angle BCD, and the angle ADC is going to be equal to the angle ABC as well. We also know something that's coming from the angle. You remember when we were talking about parallel lines with internal angles? Because of that, we know that the sum of this angle of B with the angle of A, must be 180, must be supplementary angles to each other. The same is the angle at C and the angle at D. Those are all things that can help us solving for this type of parallelograms. The last thing is that as for quadrilateral, we have similarity. Also for a rectangle, we have similarity on the diagonal. In fact, AE will be equal to CE, and BE is going to be equal to DE. Everything we just said can be applied also for the rhombus. The difference of the rhombus between with the parallelogram is that four sides, all the four sides are the same, meaning that AB is equal to BC, that is equal to CD, that is equal to DA. And AC is going to be perpendicular to BD. That means that the angle formed here are going to be 90 degrees, and that's going to be very helpful. Now, to find the area of a parallelogram or a rhombus, the formulas will be the same, which is base by height, right? Now, what's the problem? The problem is that the height in reference is this one, and sometimes it's not provided. So a formula, for example, for the rhombus can be this one, 1/2 diagonal by diagonal. For the parallelogram, most probably is going to be provided. Worst case scenario, we can draw a line here and find the height like this. But let's focus 1 second on the rhombus. We have that formula. Let's apply on it. What is the area of the rhombus ABCD above? Now, the problem of this information is, beside the fact that we have only the base, but not the height, it's also that if we want to use the other formula, we have only one diagonal, and we need to find this other diagonal. However, I know that this angle is 90 degrees. So I know that the triangle DEC is actually a right triangle. So I know I can use Pythagoras. So to find DE, I'm going to say square root of 5 to the power of 2 plus 4 to the power of 2. And this will be 3. So now I know that DE is going to be 3. And for the parallelogram theorems, also BE is going to be 3. So now we can find our area, which will be 1/2 and multiply the diagonal DB, which is going to be 6, by the diagonal AC, is going to be 8. 6 by 8 is 4. 6 by 8 is 48, divided by 2 is 24. However, that's not the only method you could have solved this problem. This is the fastest one. But let's say that during the SAT you don't remember this formula. Because honestly, we have to study so much that maybe this formula is not that important for us. We still have some way to solve it. Since this one is a right triangle, since these sides are the same, the area DEC is going to be equal to the area DA, that is going to be equal to the area AED, that is going to be equal to the area BEC. So what we need to find is the area of one of these triangles. I'm going to focus on D, E, C. That will be what? 1/2, 3 by 4, which is 6. That 6 needs to be multiplied by 4 because there's 4 triangles like that. The result will be 24. That's it. Let's start talking about polygon. Now, all the type of polygon we can run into the SAT are called regular polygon. Why they're regular? Because they are inscribed inside a circle. The characteristic of polygon inscribed inside a circle is that all the angles are going to be the same. So on the octagon, each angle is going to be the same, the hexagon the same. Not only that, also each side is going to be the same. Okay. Knowing that, we have two formulas that we need to remember for polygons. The first one is the calculation of the sum of the interior angle of a polygon, which is n minus 2 or multiplied by 180. This is a standard formula. If you, for example, want to find the internal angle of a triangle, how many sides n there are in a triangle? 3 minus 2 multiplied by 180. 3 minus 2 is 1, it's 180. And we knew that. You can do it with a square or a rectangle. This one will be 4, 180 by 2, 360, and so on. So this is a standard formula. And then if you want to find the measurement of each angle, you just divide it by the amount of angles. That's all. The amount of sides. The formula for the area will be 1/2 apothegm by perimeter. Let's start talking about the perimeter. The perimeter is the sum of each side. 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. The sum of each side will be called perimeter. We can find perimeter for any type of geometrical figure. The apothegm will be the distance between the center of one of your side through the center of the figure. Usually it will be provided. If it is not, most probably there is going to be information regarding that triangle formula right there to find the apothegm. So that's the formula to find the area of any polygon. So let's look at the example. A regular hexagon with the length of side of 4 is shown at the right. Find the area. Find the area of the regular hexagon. Now, you see what we have here is just this, but this one will correspond to PR. We know that this angle is 90 degrees, right? That means that I can divide this one by 6 to get 60 degrees for PQR, which is going to be this angle. And now I know that if I consider just the right triangle QSR, this is going to be just 30. So I have a 36 in 19 right triangle, which one of the side is going to be 2. We knew it. And now we can find the rest of the information. It's going to be find the apothegm thanks to the special right triangle, which will be 2 square root of 3. And we can just apply to find the area. That's all. Again, the proceeding is pretty simple. And that's all about quadrilateral and polygons. They are not the art figure on the SAT, so feel confident on it. Just remember those 3 formulas. The areas are provided. You just need to remember the few things we have discussed. And good luck. If you have any question, let me know in the next class. Ciao.